So I've got a little list of the things that we're going to be doing today here. We've got we're going to perform reflections. We're going to perform glide reflections, and what that means is that there'll be a reflection and also a translation. I believe that's what they're talking about glide reflections. That's a different vocabulary, but I think that's what they mean. Identify lines of symmetry, as in figure out what the line of symmetry is, and solve real-life problems involving reflections. A reflection is a transformation. Transformation means it's the same shape but in a different location that uses a line like a mirror to reflect. The mirror line is called the line of reflection. Now, reflection in a line maps every point P on the plane to a point P prime so that for each one of the following properties is true. If P is not on the line M, then M is the perpendicular bisector of the line between P and P prime. Or if P is on the line, P and P prime is the same point. Okay, so let's talk about what that means. So let's say we have, so I'm going to draw a little triangle here. There's my little triangle. And I'm going to draw a line of reflection in a different color. Okay. So let's say this is our line of reflection. So to find the other points, I'm going to change colors again. There's a line that goes to the line of reflection. If I go out the exact same distance the other way, okay, that's not perfect, but let me undo that and do that a little better. That's where the matching point is. This point and this point. See how they're exact same distance but on opposite sides of the line of reflection. And I can do that to find every single point. If I'm going from this one, again, sorry, it's not perfect, to here, see how this point and this length right here is the same as this length right here. This length is the same as this length. And of course, I can draw my other triangle. This third point right here, this is what they're talking about right here. If the point is on M, in other words, if the point is on the mirror line, the reflection line, then the point and its reflection are the same point, or its image are the same point. So that's why we got this right here. There we go. That is what made it a reflection, because the perpendicular distance to the line is the same, but just on the other side. So let me clear that off. Let's look at the next stuff. Oop. Ooh, that was fun. Okay, here we go. All right. So they've got some lines of reflection. If we started with notice point A and point A prime, they're the same distance from the line of reflection. They're both 2, but going off opposite directions. Same with B. Point B and point B prime, even though, now this is weird, A goes through the line. Let me clear what we have here. See how A goes through, excuse me, I'm saying that wrong. ABC, triangle ABC, goes through its reflection line. So when it gets reflected, at the beginning, line AC was over on this side, right? There's AC. And the reflection has AC over on the other side. But B starts off over here and ends up, B prime ends up over here. So they both, this one flipped over this side, this one flipped over to that side. This is more like the drawing that I showed you, my first one. This point C, since it's on line M, its reflection, C prime, is the same point as C is. Just it's like when I put my finger on the mirror, I'm touching the reflection of myself. Okay, let me check in with you guys real quick. How are we doing on this? Let me see. Oh, it's hard for me to do that and not ruin the recording. Let me see. Let's see. In the chat, can I get some yeses or nos, some faster or slowers? I see, and I kind of get it. Thank you. We're going to see more, but anybody who thinks I'm going too fast, let me know. Anyone need me to go back and do more? All right. So, no, I agree. I'm not finished. But do I need to re-explain what we've done here? Are we okay so far with just what you've seen? Can I go into another example, or do you have questions about this? Okay, I'm going to go on to another example since there aren't any questions. Okay, all right, thank you. Okay. So sometimes we can reflect across a line that's not, no, before we were reflecting across lines that were vertical or horizontal. Now check out reflecting across lines that are not. This point, this is where the fun starts. G and G prime are both the same distance from the line of reflection, but the line I draw to find the distance is not vertical. It's a diagonal, right? But this and this are the same length. So is this and this. The distance from F to the line and the difference from F prime to the line are the same. Now, this looks super hard. Turns out it's not. Because when you're reflecting across the line y equals x, it turns out there's a cool little rule you can use. And they're written down here, but let's just see what's happening here. This point right here, F, so F is the point -1, 2, right? -1, 2. That's F. F prime is 2, -1. That's F prime. G is 1, 2, right? Oops. 1, 2. G prime is 2, 1. Now I'm going to put a new point on here. Let's say I had, let's see, what about this point right here? It would reflect over here, right? These are both the same distance. I'm going to call this D, and this D prime. So if D is -3, -1, right? -3, -1, and D prime is -1, -3. -1, negative 3. Does anybody notice a pattern? If you do, write it in the chat. There is a simple pattern going on here. Look at each point and its reflection, its image. There's a simple rule you can use if you know if you take the first point, how you make the second point. I've got 1, 2, and 2, 1. I got negative 1, 2, 2, negative 1. I got negative 3, negative 1, negative 1, negative 3. What's the pattern? Here, I'll do another one. Okay, how about this point and its reflection here? This one is 1, 4. We've got 1, 4. Calling this A. And this is A prime. I've got A is 1, 4. A prime is 4, 1. Okay. How about this one? I'm going to call that X. All right, if that's X, oh, I don't have room for that. Erase. Okay, you guys are strangely silent. What is the rule? What's happening here? Negative 3, negative 1 became negative 1, negative 3. 1, 4 became 4, 1. 1, 2 became 2, 1. Negative 1, 2 became 2, negative 1. I know you guys can explain the little pattern here. I'm not going to say it. I'm going to wait for somebody else. Aha, Elijah. Yeah. So actually, you don't have to turn one of them negative. You just reverse them. It's even simpler than that. Look at this right here. It's simply I see you're looking at this list right here. I hadn't revealed. This is for if you're reflecting across the x-axis or the y-axis. If you're reflecting across the line y equals x, if you're going across y equals x, you just take the 2 points and switch them. Like that. If the first point is AB, its reflection is BA. If I'm reflecting across the line y equals x, I just switch the x and y around. That's all I have to do. The points that are on the line y equals x, they're their own reflection. But notice, this is the point 4, 4. Well, if I switch the y and the x around, I still get 4, 4, don't I? Tricky. Hold on, let me clear what I have here and move up a little bit. All right. So these 4 rules, and I just actually made an image of this, which I'm going to put up on the, why are you doing that? Which I'm going to put up on the website. These are the coordinate rules for reflections. This is the one we were just doing. I'm not going to do that. That's not helpful. If AB is reflected in the line y equals x, then the image is BA. This one, now this is the line y equals negative x. If the line is y equals negative x, you switch them around and you change their signs. Check this one out. Here's my annotate. So this is point F. It's negative 2, 1. I can't talk. It's negative 1, 2. Its reflection You switch them around and you change both their signs. So the 2 switched over there and changed signs. The 1 switched over there and changed signs. So like if I had 3, -7, that would go to +7, -3. There's not room for it on the graph because 7, let's make that 4 instead. So it'll be on our graph. So 3, -4 would be 3, 1, 2, 3, 4. Sorry, 3, -4 is here. 4, so that's 3, -4. 4, -3 would be 4, -3. It's right here. See it? We're trying to go, so that's a great question. Gianna's asking, why do the positive negative numbers go negative? Well, the rule is saying change the sign. So if it's original, like if let me write the rule. So the rule is AB goes to, or maps to, -B, -A. So if I took 3 and negative, so let's look at applying this rule. If I take -4 and make it negative, that's +4, isn't it? And if I take 3 and make it negative, it got the negative. But that's why. It was already negative, so when I make the negative negative, it becomes positive. And you'll notice we saw the proof of it here, right? Let's pick another random point. Let's pick, I'm going to pick another point that's got a negative in it. So let's look at this point right here. That's the point -4, 2. So if I have -4, 2. All right, can somebody in the chat tell me the answer? Oh, hold on, let me make it so the chat, let's see, let me make it so you guys can answer publicly here. Hold on. Oh, you can, okay, got it. All right, so can somebody tell me in the chat the answer to this question? What's the reflection of -4, 2? That's exactly right, Elijah. It is -2, +4. And let's see it over here. So the original number was -2, 4, and assuming -4, 2, and then -2, 4 gets me right here. It's working, right? We can see that it's working. We start with okay. Let's see. Do we want to see another example of this, or are we ready to look at another one? Does anybody want to see me do another point on this reflection? One more example. Okay. So what if we were right here? Okay. Oops. A little carried away with my drawing a point. Okay. So first, can somebody in the chat tell me what are the coordinates of this point that I just drew? Let me do it in a different color. The red point. What are the coordinates of the red point? What are the coordinates of, I agree, Gianna, thank you. That's -3, -2. We know it's -3, -2 because I'm going this way, -3, and then down 2. Okay, so the rule says that we switch them around and we change their sign. That's what this is saying. So the -3 that's in the x place is going to go as +3 in the y place. The -2 that's in the y place is going to go as +2 in the x place. Yeah, good job, Gianna. What's great about this is you get a chance, you can do them, you can do the math of them, but if you graph it, you'll if you're doing it right, the graph will look right too. All right, let me clear this. Let's look at another example. Okay. Okay. So reflection postulate. So postulates we don't prove, we just assume are true. We assume they're true because they make sense to us. Because reflection is a rigid okay, so reflection postulate says that reflection is a rigid motion. In other words, what that means is if you reflect, all the angles stay the same, all the lengths of the sides stay the same. The thing, it's rigid. It does not get bent. It doesn't get distorted or bent in any way. A glide reflection is a transformation involving a translation followed by a reflection. Yes, I was right. It is a composition. Remember before we had a composition of two different translations? We can also have a composition, they're calling it a glide reflection, which is a reflection and a translation. Right? So you can see the two-step process here. They did this translation and then they reflected. That's how you got this to go over here. So they have an example for us here. We started, here's the original guy right here. And then it got translated 12 units to the left. And then it got reflected across the x-axis. Now, we didn't talk about this before, but let me just, remember back here we had, I mentioned these 4 rules, but check out this rule right here. It says, if you're reflecting across the x-axis, AB becomes A negative B. So let's see how that's working right here, by the way. Okay, so let me write that rule. AB becomes A negative B. So they started with -9, 2. So -9, 2 became -9, -2. There's -9, -2. If you're reflecting across this way, the amount that you go up becomes the amount you go down. Or the amount you went down becomes the amount you went up because you're reflecting across this way. You can see it in action here. This point is -5, 1. Its reflection, -5, -1, because we're reflecting across the x-axis, which just has the y coordinate changes signs. Questions on that? Anybody want to see more examples on what that does? This reflecting across the x-axis, that another way of thinking of it is that we just change the sign of the y coordinate. It's because the amount we went up, all right, cool. So here's the idea. If I want to reflect this point right here, down here, the amount that I'm going up, remember in the beginning we talked about the, change colors here. We talked about that line that went through the line of reflection that, I should have used the line tool. It's the same distance, but going the other direction, right? This is 3 units going up. It's got to be 3 units going down to find the reflection, right? The reflection point. Well, that's exactly what the y coordinate is. It's telling you how much up. But instead, we want to go down. So that's what the negative does. It says go down instead of going up, or vice versa. Let's, I know this wasn't part of the original problem. Let's reflect this one across the x-axis. Okay, can someone, so C, let me change to blue here. I'm going along with this problem right here. Let's reflect this triangle down here. Can somebody, so I'm going to do, so let's see, point A is 3, 2. What would A prime be? Someone tell me in the chat what A prime would be if we reflect on this way. We're reflecting across the x-axis. Okay, so somebody gave me -2, 3. So let's look at what -2, 3 would go. -2, 3 would give me over here. That's -2, 3. Our rule is the x coordinate doesn't move. See how the x coordinate stays the same? What happens is the b coordinate, excuse me, the x coordinate doesn't change. The y coordinate, right? This is the x coordinate, y coordinate, right? The y coordinate goes from being b, whatever some b number is, to the opposite of it, -b. Okay, so Elijah says -2, -3. So -2, -3 would be down here. Let me write the rule again. The rule says AB goes to A -B. So that's right, Gianna. It's 3, -2. Right? The x coordinate stayed the same, right? A went to A, nothing changed. B just became -B. So let's have somebody tell me B. So B is 6, 3. What is B prime? 6, 3. What would B prime be? Okay, somebody tell me in the chat what B prime would be. 6, -3 is correct. 6, -3. See how it's the same distance down as this is up? That's what makes it a reflection. Okay, C is 7, 1. What's C prime? Yes, Luis and Vianney, you're both right. It is 7, -1. Because we're still going out the same amount, but we're going down instead of up. There is the reflection. Good work, guys. What would be the reflection of, let's see, let's just choose some other random points here. This point right here, oops, this point right here. First of all, what are the coordinates of this point? Somebody tell me in the chat, what are the coordinates of that point? What are the coordinates of this little point right here? Well, if this is negative 12, what's that got to be? They gave us the evens here. We've got to, it's like one of those clocks where they just have the numbers on, they don't have the numbers on all of the spots, but you can count. Still waiting for somebody to tell me what the coordinates are at that point. Oh, come on, guys. This is negative 12. What's that got to be? Dun, 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 dun. It is not negative 12. It's negative 13. Negative 13, right? Because it's one past negative 12. See, this one's negative 12. This is negative 10. So this line is negative 13. Negative 13, 4. Negative 12, 4 would have been here. But thank you, Vianney. Negative 12, 11 would have been up here somewhere. Yeah, it's not 11 because we're not, yeah, look at the scale on the y. This is just 4. Okay, so if I have negative 13, 4, what is the reflection of that point? Across the x-axis. Yes, thank you, Vianney. It is. You are correct. It is. Where'd my mouse go? Just lost my mouse. Come on, there it is. Negative 13, negative 4. Right? Because we go negative 14 and then instead of up 4, down 4. Negative 13, negative 4. All of those are reflections across the x-axis. Okay, I'm going to clear this and let's, I meant to clear that. There we go. Okay, I'm going to clear all that and let's look at some more stuff. Okay, so lines of symmetry, they're going to be asking you about that. Define lines of symmetry. It's hard to do this interactively with you guys, but just notice this has a line of symmetry that goes through these points, but also there's this, right? It's any place where you could fold it and everything would perfectly match out. I can't go this way though, because this side wouldn't match up with this side. But this guy right here has tons, this one also has tons of lines of symmetry the same way. Oh, I'm sorry, we're looking at the answers. Duh. That's so funny, I wasn't even looking forward. They have the answers here. Duh. Duh, Miss Thorne. All right, I was saying, this looks just like it is the answer. All right. Hold on. All right. So I'm going to use these right here for us to talk about how the rules work. Oh, by the way, this is the one that doesn't belong. This one's not a reflection. These others are reflections. That one's a translation, right? Because it's not, it doesn't reflect across this line, right? The triangle would have had to point down since this triangle pointed up. All right, so check this out. All right. So this is reflecting across the y-axis. When you're reflecting across the y-axis, AB maps onto Well, no, let's take a look at this. This is the point. Let's see if we can't come up with the rule. I bet we can. So this, we're gonna let the blue one be the original and the red be the image. So if we're going from 1, 5, and this point is -1, 5, right? Notice when we're going across the y-axis, it was the x part that changed. The same amount that this 1 became, this -1 became, this 1 became a -1. Who can tell me what I should write here? What's the rule this is following? I'll put another point here. This one is 2, 1, and this one is -2, 1. What's the rule here if I was making a generalization about A and B? What's happening here? You can also look in your book at that list of the rules. When we reflected across here, when we reflected across the x-axis, this was the x-axis, and the rule was A, B went to A, -B. This was for reflecting across the x-axis. This is reflecting across the y-axis. Yeah, it's right. Good job, Vianney. It's -AB, right? The first one, the x one, changed sign. The y stayed the same, the x changed signs. Here, the x stayed the same, and the y changed signs. This one is also a reflection across the x-axis. It would be following the same rule. This point here is the point -1, 2, -1, 2, and this one is -1, -2. The x stayed the same. It was the y that changed signs. Let's take a look. Hold on a second. Let me stop and restart the recording.